Good day, everyone. My name is Bruce Bartlett. I'm from the Mathematics Division at Stellenbosch. And today we're going to tell you about the Mathematical Sciences program here at Stellenbosch. So in studio with me, I've got two guests. And would you like to introduce yourselves?
Hi, good morning. This is Andy de Villiers and I am from Applied Mathematics.
Good day, I am Rita Heiman and I'm from Mathematics. So let's start. Andy, can you tell us more about the overall structure of this program?
So what typically happens is a student will identify a focal area that interests them, and this will inform your main subjects or your majors, as Bruce will explain later. And this majors is packaged or distributed throughout the years of your study, and you augment your studies with some elective courses. We have a wide variety of subjects available. Bruce, can you please tell us about the subjects that Mathematical Sciences hosts?
Okay, so broadly speaking, mathematical sciences consists of applied mathematics, biomathematics, computer science, financial mathematics, operations research, mathematical statistics, and mathematics, of course. And the thing to remember about structuring your degree is that the framework is that you will have 4 subjects in your first year, 4 main subjects, 3 main subjects in your second year, and 2 main subjects in your third year. So going from the first to the second year, you'll drop one of your subjects, going from 4 subjects to 3 subjects, and going from your second year to your third year, you'll drop another subject, so you'll have 2 main subjects in your third year. Those 2 main subjects in your third year are called your majors. And that's what you will tell your employer one day if they ask you, what are your majors? You'll say, my majors were mathematics and applied mathematics, or my majors were applied mathematics and operations research. Okay? When you graduate one day, you're going to get a little degree certificate, and it's going to say BSc in Mathematical Sciences. And then on your CV, you might say, with majors being mathematics and operations research, for example. Okay, so that's the basic idea. The university then has made it even simpler for you in the sense that it has come with some pre-packaged focal areas, which includes the various modules that you'll need to take in the various years to achieve those majors at the end of the day. So, Rita, would you like to tell us about the focal areas?
Sure. As you can see on the slide, we now have 3 focal areas and you should choose one of them. There's the Applied Mathematics focal area. If you choose this one, one of your majors will be Applied Mathematics, and there are several possible elective subjects which you can then choose from, including mathematics, computer science, economics, and operations research. Then there is the mathematics focal area. If you choose this one, then you can combine your major, which will be mathematics, with other elective subjects, including biochemistry, chemistry, physics, mathematical statistics, computer science, and or applied mathematics. Then there is the third focal area, operations research, and there will be a different set of elective modules where you can choose your other major from.
Okay, thanks, Rita. But now tell me, what is the difference between school maths and university maths?
Good question, Bruce. So at school, mathematics tends to be about solving certain familiar kinds of problems, and you learn the recipes for solving those problems, and you learn to recognize some patterns, and you learn to do some algebraic manipulations. But at university level, the focus is a lot more on understanding, and there is some creativity involved. So we like to learn to understand and also formulate logical arguments, and we learn to understand various concepts, also abstract concepts, and we develop mathematics and mathematical theory from first principles, and we also solve problems at university level, but we like to approach it in a different way, and we want to use the tools we have to solve open problems. So we need some creativity to come up with new kinds of solutions. So now that we know a little bit about university mathematics and this program, Andy, could you tell us more about what we can do with such a degree after we have studied?
Now, that's an important question, and your parents are probably also asking it. It's a little bit different from when you study for a profession like a doctor or engineer. Your job title won't be mathematician or applied mathematician. There might be something like analyst in the name, or it could be one of the requirements that you have a degree in either something like engineering, applied mathematics, or computer programming. I would like to show you some examples of students that studied at Stellenbosch, just to give you an overview of some of the jobs that you could do. So if you want to pursue a career in the academic sector, you could pursue it in the higher academic sector, like Michael Hoefnagel. He's a senior lecturer at Stellenbosch University, and his day typically consists of teaching both undergraduate and postgraduate students, but also very importantly doing research. You could also become a teacher, like Constance Botma. She's teaching at the Cow Academy. You could also have a more scientific job, for example, as a programmer, like Mark Chimes. He didn't study computer science, but he still became a programmer at a Stellenbosch-based company called Vastec, and he's now doing his PhD in computer science. Christy Rotenbach is working in New Zealand at the National Water Institute and Atmospheric Research Institute, and he's an oceanographer. Now, the buzzword today is definitely machine learning and data science. There will be several job titles where you can use machine learning and statistics to investigate patterns in huge sets of data and to come up with questions for answers in different sectors. So one of our examples is Jacqueline van Jaarsveld. She's a data analyst at Vendata. Then we have a few examples in the financial sector. Mugaba Molosi is working at Prodigy Finance, and Mbali Chola is a quantitative analyst at Nedbank. Lastly, you can just do machine learning and become a machine learning engineer like Danique Brink. She's working at IT Cognify, which is also a Stellenbosch-based company. Now, there's many more examples and job titles that you can pursue, such as a research and development engineer, financial modeler, operations researcher, supply chain analyst, script analyst, and a little bit more fun, a game designer. And you can visit these two links on the slides. The top one is an international website where they showcase jobs mathematicians do, and then the South African Mathematical Foundation also show mathematicians doing their jobs, or they have a page showcasing that.
Okay, thanks a lot, Andy, and thanks a lot to you, Rita, as well. And to you all at home, I hope that gives you a much better idea of what the Mathematical Sciences program at Stellenbosch is all about. See you on campus.